All right, so I want to make sure that you remember something as far as dividing fractions goes. So we have this fraction a over b, and it's being divided by c over d. What we learned early on is we can rewrite that as a over b divided by c over d. And when you see it in this second form, you might recognize the phrase keep, change, flip, which means you're going to have a over b times d over c. So you multiply by the reciprocal. That is the math way of dividing fractions. So what we're going to do today is take what we already know. We're going to use rational expressions, and we're going to do that keep, change, flip. We're going to multiply by the reciprocal and see if we can simplify some of these. So if you'd like to work these with me, I have 3 examples. Like I say, on your assignment, you've only got 3 of them to do. I am going to start with a more straightforward one, and then progressively get a little more complicated. The trickiest thing I think about these is finding, as you look at the textbook, okay, where is the actual division sign? And so when I've written these, I hope you can see that this top fraction is being divided by, I made a longer line, a wider line, by this one term. And when I go to do these, I automatically rewrite this as, okay, maybe I will use a different color marker. I will write this in this second form. And then I will rewrite it as a keep, change, flip, and multiplying by the reciprocal and simplify. So on my paper, if this is the problem that was in the textbook, I would say negative 2 over 11x is being divided by 18x squared over 1. And that way I fill out all 4 slots. I've got my numerator, my denominator, being divided by my numerator and my denominator. And when I get those 4 slots filled, then I can go ahead and say, well, that just means negative 2 over 11x times 1 over 18x squared. Now, since these are already ready to be canceled, we can take this 2, divide it by itself, and get a 1. This 18 divided by 2 is going to give me a 9. And that looks like the only thing that's actually going to cancel. So I'm going to multiply straight across, because when you multiply fractions, you go straight across. And I'm going to get negative 1 times 1 is negative 1. And that's going to be divided by 11 times 9 is 99, and an x with an x squared is x cubed. So that one only simplified a little bit. Usually you're able to cross out a few things and make it a much smaller fraction. But sometimes I think this number 3 that we do, it's going to end up relatively long also. So here is number 2. If you're writing it, x squared plus 4x. And again, hopefully you can see I made this one darker and wider or longer. And that's your textbook does that somewhat. So hopefully you can see that. That term is being divided by x plus 4 over x squared minus x. So my first step is going to be to write x squared plus 4x over 1. So I get that first fraction, and I know I'm going to divide it by my second fraction, x plus 4 over x squared minus x. So I just rewrite this complex fraction in a form that I'm more familiar with. Make sure you fill in your numerator, denominator, numerator, denominator. Now you can do your keep, change, flip, or your multiplying by the reciprocal. And I'm going to go ahead as I do that and factor out GCFs and things like that if I can. So GCF of this first numerator, this term, is going to be an x. and I would have an x plus 4 left. That is still over 1. Now, when I change this, I go ahead and flip. And I think you guys are totally capable of this. When you flip this, you're going to factor out that x, and you're going to be left with, if you take out an x from the x squared, you still have an x, minus if you took the x from the x, you just have a 1 there. And that's going to be divided by, because I flipped this to change this to a multiplication, you multiply by the reciprocal, x plus 4. And now you're ready to start canceling just like what we did on Monday. X plus 4 cancels to x plus 4. And again, they didn't match it to where you could cancel an x at the top and an x at the bottom. Both of your x's are in the numerator. So you end up with an x times an x would be x squared. And the parenthesis is just an x minus 1. And you ended up with just 1's in the denominator. So that is your final answer there. And last one here, and you'll see it looks quite intimidating, but actually if you think about it, you now have your numerator, denominator. So it's not as overwhelming, hopefully, as when you first looked at these. I'm going to rewrite this in the form that I'm most familiar with. Oh my goodness, what if I can't? Markers run out, we're going to be in trouble here. X squared minus, I'm going to totally run out of room on this board. We'll try to squeeze everything in. X squared minus 2x minus 8 is being divided by 6x minus 3x squared. That's my first fraction. Then I'm going to divide that by this bottom fraction. So x cubed plus 4x squared over x squared minus 4. And Monday I was like, hey, you don't have to write quite as much. You can, kind of shortcut it. This one I'm actually having I want you to rewrite the problem in a form that is familiar to you. Then you can keep, change, flip, multiply by the reciprocal, and you can do your GCF and factoring. So I recognize this is a trinomial. The lead coefficient is 1. So when I factor it, I can go straight to my parentheses. A times C is a negative 8, and B is a negative 2. Well, factors of a negative 8 would be 4 and 2 are going to give me 8. But if I need that to be negative, one of these numbers has to be negative. And when I look down here, I see that it is the bigger of the two numbers. So negative 4 times 2 is negative 8, but negative 4 plus 2 is negative 2. So my top parenthesis is going to be x minus 4 times x plus 2. I guess those are my top two parentheses. Down here, my GCF is going to be a 3x. And when I take out a 3x, divide that here, I get a 2. And when I divide 3x here, I end up with an x. I'm going to go ahead and change this to a multiplication, flipping it as I factor. So the denominator is now at the numerator, and I see that's a difference of 2 squares. So I know I can make this x plus 2 times the quantity x minus 2. And the numerator is now the denominator. Since I did the reciprocal, my GCF is just going to be x squared. And I end up with an x plus 4. Now, unfortunately, if that had been an x minus 4, that would have been a difference of 2 squares, and I could have factored it further. But since it is an x plus 4, that's as low as it's going to go there. So I start to see if I can cancel anything, and I don't see anything. But I do recognize that this is a 2 minus x, and if I could flip that around, I would have an x minus 2. If I could take the opposite and make this negative and this positive, that would be x minus 2. So remember what we did a couple lessons ago. We pulled a negative 1 out so that these two terms would actually get reversed signs. So I'm going to take a negative out of this one since I already have a 3x sitting there. And when I take a negative out, that turns the x to a positive and the 2 to a negative. And when I do that, that gives me an x minus 2 in the denominator and an x minus 2 up in the numerator. So this does not happen very frequently. But the final answer to this particular problem, we didn't get to simplify it very much, is going to be the quantity x minus 4 times the quantity x plus 2 times the quantity x plus 2. So I'm just going to square that so I don't have to rewrite it twice. But I ended up with all three of those parentheses in my numerator. So x minus 4, x plus 2, the quantity squared. All of that is being divided by a negative 3x, and I'm going to multiply that by x squared. So negative 3x cubed over x plus 4. And although that one did not simplify very nicely, a lot of these, when you have your complex fractions, they're very much contrived, meaning when you go to factor them, you're going to start canceling things left and right, and it's going to end up in a much simpler form. So have a great day, all.